AP Statistics. In this video, we are looking at your Unit 3 notes, and we're just going to talk through a few examples. So we're going to start with example 10. Make sure you read this so that you will know what you're supposed to do. I'm just going to explain to you in this context what your explanatory and response variables are. So our explanatory variable in this particular situation, notice that in the problem you're shown that the study followed more than 20,000 nurses and doctors over a 30-year period, and they gave them questionnaires about their coffee habits. So the people that are involved in this are having coffee, all right, or not. So their explanatory variable here is the amount of daily coffee consumed, because that is what they're being subjected to. So that is our explanatory variable. We seek for the explanatory variable to show a response. The response variable is length of life or mortality rate. So that is, those are your explanatory and response variables. Because we followed these people and just watched what they drank, we did not impose a treatment. We didn't tell anyone, hey, you're randomly selected to drink 3 cups of coffee a day. So that makes this an observational study because the people were not assigned randomly to drink coffee or not. Okay, so for part B, same kind of situation, we've got to look at the explanatory variable. So in this particular problem, volunteers, we're told, are randomly assigned to complete a bike ride after consuming caffeine or after a placebo. So for this, the explanatory variable is whether or not they had caffeine, and the response variable is going to be how long it takes them to complete their bike ride. This is an experiment. Why? Because volunteers were randomly assigned to do or to complete this bike ride after consuming caffeine or not. That's how you can tell it's an experiment. Okay, the next example we're going to look at is example 12. So this is an experiment problem, experiment with multiple explanatory variables. Make sure you read the question. Please keep in mind when you are identifying the experimental units, that's what we're experimenting on. Since we are adding fertilizer and water to tomato plants to see how it will affect the tomato plants, the tomato plants are the experimental units. So now we're going to list the factors in the experiment and the number of levels for each factor. Well, there are 2 factors we're involved in that we're concerned with: fertilizer and the amount of water. So I've got a factor of fertilizer and a factor of water. For the fertilizer, there are 2 levels because it either gets applied or not. And in the water factor, there are 3 levels. They're either getting 0.5, 1, or 1.5 gallons. So if I use every possible combination of levels to form my treatments, how many treatments would there be? Well, there are 2 levels of fertilizer, and there are 3 levels of water. So that gives me 2 times 3, which is 6. So there are 6 different treatments. Now we're going to list all of them, and it's a little easier once you list them to be able to see how many there are, because you're going to look at the fact that we've got fertilizer applied, okay, with each specific water amount, and we've got no fertilizer applied with each specific water amount. So that gives me 6 total treatments. So in part E, we're describing how we would randomly assign the plants to each of the treatments. Well, since I've got 6 treatments, and in the problem you are told that we have 24 similar tomato plants, I'm going to start by numbering all of the plants. So I'm numbering them 1 through 24. I'm placing these numbers on identical slips of paper. I'm putting them in a bowl, and I'm mixing them up. Then, one at a time, without putting them back in, I'm going to pull one out. And let's say the first 4 I pull out will go to treatment 1. And the next 4 I pull out will go to treatment 2. And I'm going to do that all the way up until treatment 6. That is how I would do this problem. All right. I think we'll do Yeah, we'll do the other two problems in another video.